class. Today we are going to study the basically mechanical and physical properties of metals. Before that, let us go through a bit introduction that what is materials, how they are classified, and further then the properties. Materials are basically classified into two parts, that is metal and their alloys, and second is the non-metals. In the metal and their alloys we have iron, steel, copper, aluminium. In the non-metal you know that we have rubber, plastic, cork, glass, these are non-metals. Further, metals are classified into two categories, that is ferrous and non-ferrous. In the ferrous part, we know that if the material is having iron as the main constituent, then we consider that under the category of ferrous metals. For the second case, if we are having non-ferrous, in that case, iron will not be the major constituent, and the major constituent will be of copper, zinc, aluminium. These are non-ferrous metals. Further, how we select a material for a particular application. Selection of the material. The selection of the material is done by first availability, if the availability is there or not. Second, cost of the material. What is the cost of the material which we are selecting? Third most is that the suitability of material for the particular work purpose or the application. For this, what is the suitability? We need to know the physical and the mechanical properties of the material. What are the physical property of the material? These are density, thermal conductivity, thermal coefficient of expansion, and your melting point. These are the physical properties. And the mechanical properties of the metal are further classified into 13 more categories, which we come across daily with these categories. Let us discuss that one by one. Foremost, you know that what is hardness. Hardness is basically a property of the material which show resistance to wear, resistance to scratch, resistance to abrasion, resistance to deformation. That is defined as a hardness. So, if the material is showing resistance to scratch, resistance to wear, so we can say material is hard. Okay, we can do the hardness on Vickers machine, we can do the hardness on Rockwell hardness machine. On that also we can go for the brittle hardness test also. There are 3 tests for hardness. So next is the strength. Strength is the ability of the material to resist externally applied force without breaking or the yielding. We know that the stress, what is stress? That is the deformation produced by the material over the load, by the deformation produced by the material on which the load has been applied per unit area. So strength is basically when it is producing the, not allowing the deformation to be caused. At that time we can say ability of the material to resist externally applied forces without breaking or yielding is the strength. Next is the stiffness. Ability of the material to resist the deformation is simply a stiffness of the material. Okay, so in the next part we can say if the stiffness of the material will only be caused when it has been stressed. For example, in the case of column and strut, you have studied that there is buckling. How that buckling has been induced into the material with the applying of the load. So we can say that the stiffness is the ability of the material to resist the deformation under the stress. Next is elasticity. When the material has been loaded, it changes its shape. For example, a tensile force has been applied, it's trying to come outside in the positive x direction. So there is a deformation in the material. If the deformation in the material comes to original shape when the load has been removed from the material, we can say that it is a tensile force, or we can say the material is in the elastic range. Now the vice versa case, when the material has been loaded and it does not come to its original shape, we can say that it is a plastic range or the plasticity. Ductility, ability of the material to be drawn into wires, we can say that it is a ductile material. For the brittleness, we can say the material is brittle if with the small deformation the breaking occurs. In the case of cast iron, if we talk about the iron carbon diagram, from 2.1 to 6.1 we have a percentage of cast iron in that, so at that time there is a breakage. There is a formation of ferrite, pyrite and lugerite phase formation due to which the breakage occurs. Malleability. Malleability is the special case of the ductility, you all know that. In this case, the malleability, when the material we are providing a load or we are hammering or rolling into the sheets, ability of the material to be rolled into sheets, we can say it is a malleable material. It has a wide application in the material science engineering. Toughness is the property to resist the fracture due to high impact load. When the impact load has been applied, loads are of three types: gradual load, impact load, or we can get sudden load, and third is the falling load. When there is a gradual impact load, there is an impact load onto the body and it resists the fracture, we can say that that is a toughness. Machinability. Machinability, when the material resists the cutting, material is not aligned to be provide any type of, we can say, strong deformation in it. It is the property of the material which refers to the relative case where which the material can be cut. Resistance to the cut is machinability. So resilience. Resilience is basically when a high impact load has been applied onto the material, it absorbs some energy. That absorbed energy, we can say that is the resilience. Property of the material to absorb the energy and resist the shock due to impact load is your resilience. Creep. Creep and fracture are two relative parts. Creep is just a starting, we can say, when there is a constant stress, there is a high temperature, then there is a deformation. When a part of which is subjected to constant stress, high temperature for a long period of time, it will undergo slow and permanent deformation. This slow and permanent deformation, if it is under a repetitive stress, then it becomes your fracture, or it becomes the fatigue. Fatigue, in the case of your creep, there is at high temperature, constant stress, high temperature, constant stress is there, and small, we can say, plastic deformation occurs. And if it is a continuous repetitive stress or the increasing stress, we can say that stress will be below the yield point stress, at that time fatigue will occur. So this was basically the 13 mechanical properties which we have studied. It is a general definition. In further machine design, in further your engineering mechanics, strength of material, we will be studying these in more detail.